Welcome to Chapter 7 from Connecting Networks. Today we're going to talk about securing site-to-site connectivity. In the first part, we're going to talk about some VPN fundamentals. Let's start. So, a virtual private network, as the name suggests, is a private network that is created via tunneling over a public network, which is usually the internet. A VPN is a communications environment in which access is strictly controlled to permit pure connections within a defined community of interest. And to implement a VPN, there must be a VPN gateway, such as a router, a firewall, or an ASA. Now we're going to talk about some of the benefits of VPNs. Cost savings. VPNs enable organizations to use cost-effective third-party internet transport to connect remote offices and remote users to the main site, therefore eliminating expensive dedicated WAN links and modern banks. Scalability. VPNs use the internet infrastructure within the ISPs and devices, which makes it easy to add new users. Compatibility with broadband technology. VPNs allow mobile workers and telecommuters to take advantage of high-speed broadband connectivity such as DSL and cable to access their organization's network. Security. VPNs include security mechanisms that provide the highest level of security by using advanced encryption and authentication protocols. This helps data to be protected from unauthorized access. Now we're going to talk about some of the types of VPNs, such as site-to-site and remote access VPNs. Site-to-site VPNs are created when devices on both sides of the VPN connection are aware of the VPN configuration in advance. This means that the VPN remains static and the host may have no knowledge that a VPN exists. In a site-to-site VPN, edge hosts send and receive normal TCP/IP traffic through a VPN gateway. This gateway is responsible for encapsulating and encrypting outbound traffic for all traffic from a particular site. Site-to-site VPNs are used to connect entire networks. A remote access VPN is created when VPN information is not statically set up, but instead allows for dynamically changing information, which can be enabled and disabled. Remote access VPNs support a client-server architecture where the VPN client gains secure access to the enterprise network via a VPN server device at the network edge. Internet connectivity used by telecommuters is typically broadband, DSL, wireless, or cable connection. Now let's talk about the GRE tunnels. Generic Routing Encapsulation, or GRE, is one example of a basic, non-secure site-to-site VPN tunneling protocol. This protocol was developed by Cisco, and it can encapsulate a wide variety of protocol packet types inside IP tunnels. GRE creates a virtual point-to-point link to Cisco routers at remote points. GRE was designed to manage the transportation of multi-protocol and IP multicast traffic between two or more sites that may only have IP connectivity. A tunnel interface supports a header for each of the following: an encapsulated protocol, such as IPv4, IPv6, AppleTalk, DECnet, or IPX; an encapsulation protocol, such as GRE; and a transport delivery protocol, such as IP. GRE has these characteristics. In the outer IP header, the number 47 is used in the protocol field to indicate that a GRE header will follow. GRE encapsulation uses a protocol type field in the GRE header to support the encapsulation of any OSI Level 3 protocol. GRE itself is stateless. It does not include any strong security mechanisms to protect its payload. The GRE header, together with the tunneling IP header, creates at least 24 bytes of additional overhead for tunneling packets. Now let's talk about how to configure GRE tunnels. To implement a GRE tunnel, you must first learn the IP addresses of the endpoints. After that, there are 5 steps to configure a GRE tunnel. The first step is to create an interface using the interface tunnel number command, like in the first line of the image. The second step is to specify the tunnel source IP address. In here. The third step is to configure the tunnel destination IP address. The fourth step is to configure an IP address for the tunnel interface. And finally, this is optional by the way, you must specify the GRE tunnel mode as the tunnel interface mode. GRE tunnel mode is the default tunnel interface for Cisco iOS software. In here we can see some commands used to verify the tunnel configuration. The show IP interface brief determines whether the tunnel interface is up or down. In here we can see that it is up. The show interface tunnel command verifies the state of the GRE tunnel. We can see that it's up, the IP address, and the source and destination addresses. The show IP OSPF network is used to verify if an OSPF adjacency has been established over the tunnel interface. Now let's talk about IPsec or Internet Protocol Security. IPsec can be summarized as follows. It is a framework of open standards that is algorithm independent. It provides data confidentiality, data integrity, and origin authentication. IPsec acts at the network layer, protecting and authenticating IP packets. IPsec security services provide 4 critical functions: confidentiality, data integrity, authentication, and anti-repay protection. Now, let's talk about the framework. VPN traffic is kept confidential with encryption. For encrypted communications to work, both the sender and the receiver must know the rules that are used to transform the original message into its coded form. Rules are based on algorithm and associated keys. Decryption is extremely difficult or impossible without the correct key. The degree of security depends on the key length of the encryption algorithm and the sophistication of the algorithm. There are 2 kinds of encryption algorithms used to protect the message: the symmetric and asymmetric encryption. In symmetric encryption, each device must know the key to decode information. As we can see in the image, the key is the same. In asymmetric encryption, you must use 2 keys to secure the message. One key encrypts the message, and the second key decrypts it. Knowing one of the keys does not allow a hacker to deduce the second key and decode information. Some examples are RSA. In here we talk about Diffie-Hellman, which is a method to securely exchange the keys that encrypt data. This algorithm allows 2 parties to establish a secret key that is used by encryption and hash algorithms. A Diffie-Hellman key exchange is based on a mathematical sequence of steps. So, what is a hash? Hash is also called a message digest. It is a number that is generated from a string of text. Hashes provide data integrity and authentication by ensuring that unauthorized persons do not tamper with transmitted messages. To determine whether the communication path is considered secure, the device on the other end of the VPN tunnel must be authenticated before the communication can be established. There are two peer authentication methods: the pre-shared key or PSK, in which a secret key is shared between two parties using a secret tunnel before it needs to be used, and RSA signatures. In here, the local device derives a hash and encrypts it with its private key. The encrypted hash, or digital signature, is attached to the message and forwarded to the remote end. At the remote end, the encrypted hash is decrypted using the public key of the local end. If the decrypted hash matches the recomputed hash, the signature is genuine. We have been talking about site-to-site VPNs. In here, the last part of Chapter 7, we're going to talk about the remote access. Secure socket layers, or SSL, and IP security, or IPsec, are the two primary methods used to deploy remote access VPNs. SSL VPN offers anywhere connectivity. The SSL protocol supports various cryptographic algorithms for operations, such as authenticating the server and client to each other, transmitting certificates, and establishing session keys. In here, we're going to talk about the IPsec remote access VPNs. Many applications require the security of an IPsec remote access VPN connection for authentication and encryption of data. The Cisco EasyVPN solution feature offers flexibility, scalability, and ease of use for both site-to-site and remote access IPsec VPNs. The Cisco EasyVPN solution consists of three components: Cisco EasyVPN Server, a Cisco EasyVPN Remote, and a Cisco VPN Client. In Cisco EasyVPN Server, the Cisco iOS router or Cisco ASA firewall acts as the VPN head-end device in site-to-site or remote access VPNs. The difference with Cisco EasyVPN Remote is that it acts as a remote VPN client. The Cisco VPN client allows organizations to establish end-to-end encrypted VPN tunnels for secure connectivity for mobile employees or telecommuters. Now let's compare both technologies. Both of them offer access to virtually any network application or resource. IPsec exceeds SSL in many significant ways, such as the number of applications that are supported, the strength of encryption, the strength of authentication, and overall security. When security is an issue, IPsec is the superior choice. If support and ease of deployment are the primary issues, you must consider SSL. IPsec and SSL VPNs are complementary because they solve different problems. This is the end of Chapter 7. Welcome to Chapter 7 from Connecting Networks. Today we're going to talk about securing site-to-site connectivity.